Welcome back. This is Mr. Tipton, and today we are talking about the mean absolute deviation, MAD for short. It sounds pretty terrible, mean absolute deviation, a couple big words in there. It's not actually too bad. Really all it is, if you can find an average, if you can find a mean, you can do this, okay? The MAD is the average distance between each data value and the mean. Okay? The smaller the MAD is, the more reliable the mean is, because that means your data is less spread out. Okay? We've talked before about if your data is really spread out, if you've got some extreme values or some outliers, you want to probably use the median instead of the mean. But sometimes, it's tough to tell. Maybe it doesn't have outliers. Anyway, this mean absolute deviation is going to let us know how reliable our mean of our data actually is. Alright, so let's calculate some MAD. Let's do some MAD calculating. Find the MAD of the points scored here. First thing we're going to have to do is find the mean. We can't find the mean absolute deviation unless we find the mean. Alright, so we add everything together. 17 plus 22 plus 17 plus 30 plus 15 plus 17 plus 8. I did it ahead of time. I got 126. Double check me in the calculator if you want. Maybe I'm wrong. It's happened before. Then we divide by 7 because there are 7 points of data that we just added. 126 divided by 7 gives us a mean of 18. Now, here's where the mean absolute deviation comes in. I'm going to list our different points scored here. What do we have? 17, 22, a 17, a 30. I'm actually going to separate this. 15, 17, and 8. I'm going to take us back a screen to look at the definition again. It says the average distance between each data value and the mean. The distance between each data value and the mean. Well, we know the mean is 18. So what we need to figure out is how far away is each data value from 18? Okay, how far away is 17 from 18? It's 1 away. Okay, how far away is 22 from 18? It's 4 away. How far away is 30 from 18? 30 minus 18 is 12. How far away is 15 from 18? 18 minus 15 is 3. 17 we know is 1. And how far away is 8 from 18? It's 10 away. Alright, so what happens now is we're finding the average distance that all the data is away from 18. So we have to find another average. We're going to do 1 plus 4 plus 1 plus 12. We're adding up all these green numbers. Plus 3 plus 1 plus 10. We add all those together and we get 32. And how many numbers did we add? 7. 32 divided by 7 gives us an ugly decimal that we're going to round to 4.57. This is the mean absolute deviation. It means on average, each number of points scored is about 4.5 points away from the average. Okay? Let's do another. You can feel free to pause, rewind, rewatch, no big deal. Find the MAD. Mean absolute deviation. We have a little different format for our data here. We've got a dot plot. You've probably seen these before. You know, this means you have one, girls' heights in inches. There's one girl that's 59 inches tall, one that's 61, one that's 62, one that's 63. 3 girls are 64 inches tall, and then there's one girl that's 67 inches tall. All right, let's start by finding the mean of all the girls. And again, we're adding all these together, 59 plus 61 plus 62 and so on. I did it beforehand. I got a total of 504 divided by the 8 girls. 1, 2, 3, 4, 5, 6, 7. There are 8 girls that I added together to get a mean of 63. Mean absolute deviation, the MAD. On average, how far away is each one of these dots from the mean, which is 63? On average, how far away is everything? Okay, I'm going to write down my different data values: 59, 61, 62, 63, 64, 64, 64, and 67. We need to go back. How far away is 59 from 63? It's 4 away. How far away is 61? It's 2 away. How far away is 62? 1 away. 63 is 0 away from 63. The 64s are all 1. And the 67 is 4 away from 63. Okay, again, I'm going to add all those together. I've got a 4 plus 2 plus 1 plus 0 plus 1 plus 1 plus 1 plus 4. Add all those together and we get 14 divided by the 8 numbers, 8 data items we added together. That's going to give us a mean absolute deviation of 1.75. Again, the closer a MAD is to 0, the more reliable the mean is. Okay, those were 2 examples about calculating the MAD. One question comparing. It says, which dot plot has a more reliable mean? Which dot plot has a more reliable mean? And what does that mean? It means a lower MAD. And we could specifically figure out, down to the decimal point, which one is lower. And sometimes it's good to do that, but we don't need to do that with this one. Because let's look. We're talking about, which one's more reliable. A higher MAD means the data is more spread out. A lower MAD means the data is closer together. It's more reliable. So if we look at these high temperatures, we've got a range all the way from 68 to 85. These temperatures are spread out over 17 degrees. Whereas the low temperatures go from 44 up to 52. They're only spread out over 8 degrees. So we know, because the data is less spread out, the low temperature has a more reliable mean. If we were to do all the calculating that we did in example 1 and example 2, the low temperatures would have a MAD closer to 0. I hope that makes sense. The data is less spread out. The MAD would be closer to 0. It means the average of all those dots is more reliable for low temperatures than it is for high temperatures. Okay? I'm not going to write all that out that I just said, but that's the answer. Okay? Thanks for listening. It's kind of different. Mean absolute deviation. This is something new. Please, 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 if you have questions, make sure you're ready to ask them in class, and I will see you soon.